Hey guys, let's look at this question. It's a very good question and it involves multiple concepts of geometry. So you can pause the video and give it a try, and then you can resume the video to look at its solution. So I'll read the question once. A cone of radius 90 centimeters and height 120 centimeters stands on its base. It is cut into three parts by two cuts parallel to its base, such that height of the three parts from top to the bottom are in the ratio of 1 is to 2 is to 3. What is the total surface area of the middle part? Okay, we have to find out the total surface area of the middle part. Okay, so the situation would be something like this. Okay, the bigger triangle resembles your original cone. The original cone has been broken down into three parts. This is our first part, the first cut. This is our second cut, the middle part. And the bottommost part will be this, okay, the big trapezium. All right, we want to find out the surface area, the total surface area of this middle portion. Now, this middle portion is a frustum. Now, I don't remember it anyway, and I also don't recommend that you mug it up because if you're aspiring for any entrance exam, they will not give you any question based on formulas as such. So we have to use logic here. Now, this portion, the middle part, it's also called as a frustum. Frustum. It's a frustum. So for a frustum, the diagram would be something like this. We have a circle above, then we have this, and then we have a circle below like this. This is your frustum, okay? So how to visualize this question? We simply need to understand, I can extend the frustum to form the upper part of a cone, right? So this bigger cone minus the smaller cone gives you this frustum, right? So for the curved surface area, I can find out the curved surface area of the big cone. From that, I can subtract the curved surface area of the smaller cone. So I'll get this area, the curved surface area of the frustum, right? And I also need the areas of two circles, the upper one, the smaller circle, and the lower one, the bigger circle. I want the areas of these two circles. So that's how I'll approach the problem. I need to find out the surface area of this frustum. That is the surface area, the curved surface area of the bigger cone minus the smaller cone. And from that, I can get the surface area, the curved surface area of this frustum. To that, I'll add the areas of these two circles. Now, it might look very complex, but it's not so. So let's start calculating. Let's start looking at the problem. Now, it may look to be slightly complicated, but trust me, it's a very simple problem once you understand what is to be done. So let's start solving. So the radius of the cone is 90 centimeters. The original cone has a radius of 90. So this radius here is 90 and the height is 120. So this entire thing is like 120. This angle is 90 degrees, obviously. The entire height of the big cone is 120. Now, this is obviously 3 into 30 and 4 into 30 gives you 120. So in this big right angle triangle, let's call it as ABC. AC is the hypotenuse. If it's your 3, 4, 5 triplet, the hypotenuse will also be 5 into 30. That is 150. Okay, guys. So we have found the overall hypotenuse of the big right angle triangle is 150. Now, let's call these points as D, E, and F and G. Okay. We can observe that all these angles are 90 degrees. And if I consider three triangles now, triangle ADE, triangle AFG, and triangle ABC, all the angles will be 90 degrees, ADE, AFG, and ABC, and A is the common angle. So all these triangles are similar by the AA test of similarity. And since the triangles are similar by the AA test, I can now say that the ratio of the corresponding sides shall be equal. So AD is to AF is to AB, this ratio, AD, AF, and AB, the ratio of the heights of the three cones will be equal to the ratio of DE is to FG will be equal to BC. The ratio of the radii of these three cones will be equal to AE is to AG is to AC, the ratio of the slant heights of these cones. Now, from the question we have been given, AD is to DF is to FG as 1 is to 2 is to 3, right? So if AD corresponds to 1, DF corresponds to 2, then AF will correspond to 1 plus 2, 3. So if I take AD as 1, AF will be this 1 plus this 2, 1 plus 2, 3. And AB will be 1 plus 2 plus 3, that is 6. So AD is to AF is to AB is 1 is to 3 is to 6. And similarly, guys, we can say DEFGBC will also have the ratio 1 is to 3 is to 6. And similarly, AE, AG, and AC will also have the ratio 1 is to 3 is to 6. Sorry, this is not 60, it is 6. Now, using the values AB, BC, and AC that we already know, we can figure out all these remaining lengths, right? So AD is to AB is 1 is to 6. So if AB is 120, 6 corresponds to 120, then 1 corresponds to 20. That means the height of this cone is what? 20. Similarly, AF will be thrice. AF will be 60. So this entire length is worth 60. And AB we already know is 120, not an issue. Similarly, if BC is the radius, BC we know is 90. 6 corresponds to 90. That means 1 corresponds to 15, the radius of the smallest cone here. So DE is 15 and FG is thrice. So FG is 45. And same thing we can say for the slant heights also, guys. AC corresponds to 150. So 6 corresponds to 150. 1 corresponds to 25. AE is 25. AG will be thrice and AG is nothing but 75. And AC we already know is 150. That's it. Our job is almost done. So let's find out the curved surface area first. The curved surface area of the cone AHG, the bigger cone will be pi RL. So pi into 45 into 75. From that, we'll subtract the curved surface area of the smaller cone, pi into 15 into 25. 45 is 15 into 3 and 75 is 25 into 3. So pi into 15 into 25 common, we'll have 3 into 3, 9 remaining, 9 minus 1, 8. So curved surface area will be pi into 15 into 25 into 8. And to that, we simply have to add the areas of these two circles here. Smaller circle with radius 15, pi into 15 square, plus pi into 45 square. And that's it. When you add all of them, you'll get your answer. So let's add all of them now. The first part, pi into 15 into 25 into 8, pi into 15 square. The second part, pi into 45 square. The third part. So solving this, 25 into 8 is 200 and 15 is 3000 pi plus 15 square is 225 pi and 45 square is 2025 pi. So 2025 and 225 will be 2250 and to this you are adding 3000. So you'll get 5250 into pi. So this 5250 comes out to be a multiple of 7. Perfect. Write the pi as 22 by 7 and I think you have your answer. 7 sevens are 49, 7 fives are 35 and 0. So 1500 into 11, 22. I'm splitting as 2 into 11. The answer is 16,500 centimeter square. Amazing question. Lots of concepts put into one, but not difficult anyway, because if we understand the concept once, it's a very, very easy question. So I hope you guys have understood this. So let's look at a slightly simpler, a relatively simpler way of solving this question, guys. Now, I'm not saying it would simplify it to a great extent, but at least if you're conceptually good in geometry, if you're good in the concept of similarity of triangles, then this could this could be a slightly better way to solve the question. Okay, so let's again name these points as A, B, C, then D, E, F, G, and then H, I, and J. All right. Now observe that triangles AIE and AHG and AGC, they are basically projections of three cones, AIE, AHG, and AJC, right? And these three triangles are also going to be similar by the AA test, right? There are multiple ways of proving. You can call these as parallel lines, IE, HG, and JC. They are cuts made parallel to the base, right? So these could be corresponding angles and A would be the common angle, or these are corresponding angles as well. So these three triangles are similar by the AA test. Now, whenever triangles are similar, guys, we know that the ratio of their areas is equal to ratio of their sides. So if this is the triangle AIE, the area is proportional to, and this is your triangle AHG, and this is your triangle AJC, the ratio of their areas will be square of the ratio of their sides. So AD is 1, DF is 2, and FB is 3. That means the height of the smaller cone would be 1, height of the bigger cone would be 1 plus 2, 3, and height of the biggest cone would be 1 plus 2 plus 3, 6. So the ratio of the areas will be square of the ratio of these sides, 1, 3, and 6. Okay. Now, again, this angle is 90 degrees. BC is the big radius, 90. And AB, the entire height is worth 120. This entire thing is 120. So we have already seen by Pythagorean triplets, AC would be 150. From this, we can find the curved surface area for the big triangle, pi RL, pi into 90 into 150. Now, the ratio of the heights we have found are 1, 3, and 6. So the ratio of the curved surface area will be 3 square 9 and 6 square 36. So the ratio of the curved surface areas of AHG and AJC will be 9 is to 36. That's 1 is to 4. That means if this entire area is pi into 90 into 150, the curved surface area of AHG will be 1/4 of this value. We can divide both these numbers by 2. So pi into 45 into 75. So it's a very good way of visualizing the question, guys, if you can look at it this way. Similarly, the ratio of the areas of AIE and AJC will also be 1 is to 6 ka square. That means square of 1 and 6 ka square. 1 is to 36. So if this area is given to us, the area of AIE, the curved surface area of AIE will be this entire thing divided by 36 or into 1 by 36. So we can divide both these numbers by 6. This will be pi into 90 upon 6 is 15 and 150 upon 6 is 25. So the curved surface area of this frustum will be difference of these two numbers directly. And that we have already seen will come out to be 3000 pi. Similarly, we can use the same ratio 1 is to 9 is to 36 as the ratio of the areas of these base circles. So the base circle of AGC will be pi into 90 square. So the base circle of AHG will be 1/4. 90 into 90, both sides are divided by 2. So pi into 45 square. And the base area of AIE, this circle, will be pi into 90 square divided by 36. That's pi into 15 square. So to 3000 pi, we will now add these two values. Pi into 15 square plus pi into 45 square, which is exactly what we have got previously. The same answer. And this could be a slightly better approach. The only point is you have to get this ratio correct and then need to manipulate the things properly, like 1 by 4 and then 1 by 36, like that. All right. So I hope you guys have understood this. For more details and for a better understanding of geometry and all its principles for CAT and other exams, you can join my course as given in the link below. See you all next time. Bye-bye.